I'd like to speak something related to the difference between Schottky defect and frenkel defects. നമുക്കറിയാം ഈ ഷോർട്ട്കി ഡിഫക്റ്റും ഫ്രാങ്കൽ ഡിഫക്റ്റും എവറി വൺ ഓഫ് യു നോ ദാറ്റ് ദിസ് ഷോർട്ട്കി ഡിഫക്റ്റ് ആൻഡ് ഫ്രാങ്കൽ ഡിഫക്റ്റ് ആർ ടു ഡിഫറെൻറ്റ് ക്രിസ്റ്റൽ ഡിഫക്ട്സ്. If we want to compare these defects, there are 6 major differences are there in between these two. The first difference is what? Let's move to the first difference. When you look into the nature of defect, in the case of Schottky defect, it leads to the missing of the cations and anions in the appropriate proportion to maintain electrical neutrality. That means number of cations, number of anions missing in the case of Schottky defect are same. But when you look into the case of frenkel defect, you can see that in frenkel defect, what happened? The interstitial positions are occupied by the cations. That means cations were shifted from their actual location to the interstitial location. Let's check the next fact. What is the nature of the crystal in Schottky defect and frenkel defect? When you look into the nature of crystal in Schottky defect and frenkel defect, you can see that the nature of crystal in the case of Schottky defect, the size of cations and the anions are almost same. That means the size of cations and anions are comparable in size. And at the same time, when you look into the case of frenkel defect, you can see that in frenkel defect, the size of or the radius of cation is too small compared to the radius of anion. That means cations are able to occupy in the interstitial space of anions. That is a key point. When you look into such cases, you can see that there are several examples for such small cations containing ionic compounds. Example, silver bromide, silver iodide, zinc sulfide, etc. When you look into the case of Schottky defect, you can see that the best example for Schottky defect is NaCl and KCl. Next one is change in dielectric. When you look into the case of Schottky defect, the dielectric effect is does not significantly affected or significantly changed. But when you look into the case of frenkel defect, what's happened in the case of frenkel defect? In the case of frenkel defect, due to accumulation of the like charges in a small region, dielectric constant is significantly increased. Dielectric constant significantly increased in the case of frenkel defect. Next one is electrical conductivity. When you look into the case of electrical conductivity in Schottky defect is mainly due to the movement of holes. But when you look into the case of frenkel defect, it is due to the movement of both holes and interstitial ions. Next important point is density change. When you look into the density change in Schottky defect, you know that in Schottky defect the density is generally significantly reduced in the case of Schottky defect. When you look into that case, you can see that equal number of cations and equal number of anions is missing from the crystal lattice. That is why the density of the crystal is reduced drastically. But in the case of frenkel defect, you can see that only cations are shifting from the actual site to interstitial site. Because of this, we know that the density remain unchanged. Next one is energy requirement. Very small amount of energy is only required to create Schottky defect. But in the case of frenkel defect, large amount of energy is required. These are the main differences between Schottky defect and frenkel defect.